chemistry. Welcome back, and today we're going to talk about solutions. So solutions are homogeneous mixtures of two or more substances, and we all know examples of solutions, but what you need to know, we're going to get back to that in a minute, what you need to know is what makes up a solution. It has two parts. It has a solute and a solvent. The solute is what is being dissolved. It's usually the thing that's lesser in the solution. Then you have the solvent, which is the dissolving agent. It's what's doing the dissolving, and it is usually the thing that's found in the greater quantity. So what's an example of a solution? You have salt water, and salt water is made up of sodium chloride and water, NaCl, H2O. NaCl is the solute, and water is the solvent. So those are the basic parts of a solution. Okay, so types of solution. Because we have solute and solvent, and we have three states of matter, we can have different combinations of those states of matter to create different kinds of solutions. So we can have a gas as a solute and a gas as a solvent. An example would be air. You've got oxygen and nitrogen. You've got carbon dioxide and oxygen. You have lots of things mixed together. They're all in the gaseous form. Then you can have a gas as a solute and a liquid as a solvent. An example of that is soda. So when you open your soda, you hear that effervescent sound. That sound is caused by the gas escaping from the liquid. You don't see all of the gas because it's invisible, but afterwards you see the bubbles. They're coming up from the soda. They've been dissolved in the soda. Liquid as a solute and gas as a solvent. So you might say, how can a liquid dissolve in a gas? Well, think of hot summer muggy days. That is water dissolved in air, gas. Liquid solute and a liquid solvent. We're all familiar with liquids and liquids, so an example of that, one of my favorites, is coffee and my creamer. Solid solute and a liquid solvent. Another great example, coffee and sugar. I like coffee, sugar, and creamer, but you might just like coffee with sugar. Solid solute, solid solvent. An example of that is bronze. Bronze is made up of tin and copper together. Together they make bronze. So that is a mixture. Okay, factors which affect solutions. Not all things dissolve at the same rate, the same length of time that it takes for something to dissolve. So there are three main factors that affect how a solution or how a solute dissolves. The first one is increasing the surface area. So surface area is the amount of exposed sides. So you have a cube, a sugar cube, and sugar crystals. A sugar cube is going to take much longer to dissolve than the sugar crystals. Think your sugar cube from old Victorian times. They put it in tea versus nowadays, what do we put in tea? Very rarely sugar cubes. We put in our Splenda or our Sweet and Low. It's going to dissolve really quickly because the particles are so fine. Second factor is agitation, how much you're stirring the object. So we have our glass, it's got a sugar cube in it. We're just going to let it sit there. Eventually it will dissolve without any help. The water will do all the dissolving. But then if we stir it, the stirring, the movement of the water over the cube is going to make it dissolve a lot faster. The third factor is temperature, how hot the solvent is. So the hotter the solvent, the faster those molecules are moving. Remember, temperature and kinetic energy, faster they move, the more they're going to break down the solute. So you have a hot cup of coffee, you put your sugar in, it dissolves no problem. You have your cold coffee in a mug, which is a little corny, but you have your cold coffee in a mug, and when you add your sugar to it, it's going to take a lot longer to dissolve, which is one of the reasons that you use Splenda or Sweet and Low, because the smaller size is going to counteract the temperature, and they're much lighter than sugar, so they're also going to dissolve faster. Okay, so solubility. Solubility is the amount of a substance required to form a saturated solution at a specific temperature. So how much stuff you can dissolve at a certain temperature. And we have three types of solubility states. We have an unsaturated, or we have a saturated solution, we have an unsaturated solution, and a supersaturated solution. Saturated means it's the max amount of solute per solvent. So it's the most solvent that can totally be dissolved or separated by the amount of solvent. Unsaturated is less than the max. Supersaturated is more than the max. So supersaturated is way above, and a lot of times when you're way above, you have stuff that's undissolved at the bottom. So think about your cold coffee. If you add in too much sugar and you can't get it all dissolved, you drink your coffee, and then when you get to the bottom, you find this sugar sludge at the bottom. That sugar sludge is the undissolved sugar that your coffee couldn't dissolve. Because the coffee was cold, it is less soluble, so you can't get as much stuff dissolved in it. And that means that you're going to have more left over. Because it's already reached its saturation point, it's holding the most it can, and everything else falls to the bottom. Okay, so how is this used? The way it's used is by creating solubility tables. And solubility tables are lots and lots of different compounds. They've been calculated to figure out how much solute can dissolve in a certain amount of solvent at different temperatures, and then those are plotted on a graph. So on the bottom we have our temperature in degrees Celsius, and along the side on our dependent variable you have the mass of solute in 100 grams of water. This 100 grams is very important because it tells you how much solvent you have. So if you have more than 100 grams, then you have to factor that in. So we have silver nitrate, AgNO3, here the green line, and then we have Ki, potassium iodide, the purple line. So those two compounds, we're going to talk about how much stuff can be dissolved at different temperatures. So for a solution to be saturated, you're going to be on the line. That's the max that can be dissolved at a certain temperature. Unsaturated is anything below the line, and supersaturated is anything above the line. So if I were to ask how many grams of AgNO3 can be dissolved at 40 degrees, we'd go to 40 degrees, draw a line up to AgNO3 line, and then we'd come over here. So this is tens, 10, 20. So 20 grams, well just over 20 grams, so say 22 grams of AgNO3 can be dissolved in 100 grams of water at 40 degrees Celsius. So that's for AgNO3 for a saturated solution. What about 40 degrees for potassium iodide? Can we get the same amount? So 40 degrees, we go up to the Ki line, we pull it over, and we find that there's about 12 grams of Ki that can be dissolved at 40 degrees. That's our saturated solution. So what about supersaturated and unsaturated? So at 40 degrees, anything over 12 grams for potassium iodide is supersaturated. Anything below 12 grams is unsaturated. For AgNO3, anything above 22 is supersaturated, and anything below 22 is unsaturated. And you could do that for whatever compound you're looking at. And those are solubility charts. Thanks, chemistry.